So just before we start, I figured we'd go over this little picture right here, and then we'll introduce the people who are going to be doing this. But if you notice, the cat or the little baby right now is pushing, and the cat is pushing, but notice the baby's getting up. Gravity is holding the baby down, and the cat is helping the baby to understand how to defy gravity by using the little cart to push. So that's what we're going to be learning today. We will start now. Okay, I'd like to introduce the two people that we'll be working with, or the three people. We have Charlie here in the middle. Charlie is our resident skeleton. He's plastic, so don't worry, but I'll be using him later on as a prop. My name is Dr. Joyce Bluford. Most kids call me Dr. Joyce. I'm a scientist that works with the earth. And I'd like to introduce Phoebe Chen.
Hi, I'm Phoebe. I'm a college student right now, but I've been volunteering with Dr. Joyce since I was in high school.
So together, we're going to have you guys understand what forces is all about. And we're going to look at different interactions, and we're going to have lots and lots of animations that will help guide so you can understand what is going on in the earth. You have to remember that we are on earth, and we have something pulling us down and keeping us on earth. Because as you know, the earth really does spin around. And when it spins around, you would think we'd be like a merry-go-round where we would go off, but we don't. So look at this little picture here of the boy trying to pull his sister up. Now, why is she going back down? Well, that's because she's probably on a hill. And what people do, and people who study forces are called physicists. Let's say that word. Physicists. Physicists are people who look at the world around them and try to explain it. And we're going to see some physicists later on in the presentation. But today we're going to look at how things interact with each other. We're going to look how gravity, especially on Earth, gets this push and pull. So whenever you have a push, you have a pull. Like the little boy there, what is pulling? The little boy is pulling with his muscles, but the little girl is pushing backwards. Gravity is kind of pushing her down. And so he's trying to get around it. So we're going to forces when you look at what we see on Earth. It's almost like a positive and negative, or a north and a south. We're going to learn all about some of these forces on Earth. We're also going to learn for every action, there is a reaction. And we're going to look at how motion can make things faster and slower. So are we ready for the challenge, guys? Let's take a look at some of these. Thanks, Phoebe. Phoebe will come back later on in the show. Okay, now let's figure out, are forces all around us? When you're on a merry-go-round, do you have to hold on? Because if you don't hold on, what happens to you? You might fall off, like the moms here and dads are holding their child, because there's a force created by motion. And we're going to find out that motion, because we rotate and revolve in the universe, it creates all this motion. And sometimes we don't even think about it. We try to avoid it. Just like when we stand up straight, like Charlie here, if you look at Charlie here, he stands up straight because he has bones inside of him. Like a jellyfish can't do this. And so we are designed, because inside of us, we have these skeletons. And the skeletons help us to defy gravity. And so even the way we're created will depend upon how we interact with our Earth. So merry-go-round, if we're not hold on, we will fall off. Okay, now let's look at this little wind-up toy in here. Now, if we just let it sit there, it just sits there. Gravity is actually stopping it, but what's happening there is inside there's gears. So inside that little wind-up toy is something that you see at 2. So number 2 is inside. So motion, so engineers have designed toys to move in one direction, or to avoid gravity. But otherwise, if the gears aren't working, it just sits there. Okay. Now, what happens when you don't have a floor? Oh my goodness, what's going to happen? Now, you know, your parents always tell you to look where you're going. These two little boys are obviously not looking. But what happens? Is gravity pushing them down? Yep, it is. Because if it didn't, then if they put their foot on the outside, they wouldn't fall. But gravity is bringing them to Earth. Gravity is kind of weird. So you got to, even though you don't think about it, gravity is on with you all the time. Okay, now let's look at this little boy. Oh my goodness, is the Earth moving? Or is that the mom taking a photograph so his child don't look like he's wobbling? But what is he struggling with? He's just learning how to walk, and he's trying to find what we call the center of gravity, which if you look at Charlie here, it's inside of him. And so he's trying to learn how to walk under gravity. His bones are getting strong enough. And so it's not the Earth moving, it's him trying to struggle with how to walk in gravity. Because as you know, all babies kind of crawl a little, and that's because their bones aren't strong enough to defy the gravity that's going into the Earth. Okay, now look at this little girl. Oh my goodness. Can that force of the water be that strong to pull that baby up? Yes, it is. And so it's that water is making, the force of that water makes her defy gravity. But once the force isn't good enough, what happens? Boop, down on the ground. So gravity is controlling us without us really realizing that. Now, do other animals have to learn about gravity? Well, maybe they don't have to go to school and learn why it's doing, but look at this little baby elephant. The mommy's helping the baby to get this center of gravity, so the baby learns how to get up on her own. And so the baby is getting up, the legs are, because when a baby elephant is born, its muscles and its bone structure is already there to defy gravity. Humans, on the other hand, we're not ready to walk when we come out, but most animals are already. So even elephants have to think about gravity to get up, because if you don't get up, oh, you're in trouble. Okay, now we're gonna show you some series of things that you might see every day, and I want you to kind of take a look at what is going on. So on this little video that Phoebe is going to do, I want you to look at the liquid. What is attracting it down?
When we flip this, why does the green fluid fall down?
Is it being attracted by gravity? And what makes, if you think about it, let's take a look at this again.
When we flip this, why does the green fluid fall down?
So this is what we call a density timer. There's two different densities of liquid in here. The green is more dense, or its mass is more than the white liquid, and so gravity pulls the one with the more mass down. So gravity attracts just about anything. Okay, now all of you, I'm sure, have tried hula hoops. Some of you might do it and some of you can't, but look at this little girl. What is she doing to keep it up? She's using her hips to move it up and around. That is the secret of hula hoops. You're using the hips, but you're making the hips go upward in order to go around. But once she stops, what brings it down? Hopefully everybody is saying gravity. Gravity is bringing it down. Now, we're noticing, if you noticed in the last little video, the liquid was moving around. Something with motion is going to be like anti-gravity or push and pull. So here, what's pulling it down? Gravity. Okay, now same way, we're going to take a look at a yo-yo. Like some people, especially kindergartners, might not be able to do a yo-yo. And that's because we want you to take a look at what Phoebe tells you. She's going to give you some clues of how to make a yo-yo work. Because if you remember, if you look at the little girl on the left-hand side, the yo-yo doesn't come back. There's a secret to make it come up. Let's see if Phoebe can show you.
Let's see how yo-yo works. Keep an eye on my hand.
Watch your hand. So gravity is pulling it down. It's being pulled to the earth by gravity. And then her hand with the string, if you notice, her hand goes up and down. And if you look on the left-hand side to the hand with the yo-yo going up and down, that's wrong, but that's an animation. That's not a real person. You need, and let's look at Phoebe again. She's going to demonstrate how a real yo-yo goes. You have to have the string.
Let's see how yo-yo works. Keep an eye on my hand.
So again, motion is almost like an anti-gravity. You have a push and you have a pull. Okay, now let's see a force behind hitting a ball. Now let's think, if that person was hitting the ball and the catcher wasn't there, what would happen to that ball? It would continue. That's actually what happens on Earth. A force that continues will continue on its path until another force, like the young man there, grabbing it and catching it. So forces, even in sports, now even the man who's kicking it, the soccer ball, he knows how to kick it to go right to him. If you don't know how to kick it, it could go anywhere. So the forces to defy gravity, you have to kind of learn. That's why in sports, you keep going over and over until you understand how the force of gravity is affecting your ball or whatever sport you might be working on. So there's all these forces. Now, we're going to read, Phoebe's going to read a little story about Mugambi's moving moon, because it's important to understand that all these forces are all over the place. Especially, I'd like you to notice, is Mugambi goes from Africa to the United States, and it can see the moon in both places. Let's think why. So here is Phoebe.
Mugambi's Moving Moon by Cassie Fries, animated by Doris Rea and Hagos Tawaldi, read by Phoebe Chen. Mugambi loved living in Africa. There was so much to see and do. Lions, zebras, monkeys, and giraffes, these animals are just a few. But Mugambi was moving, and he had to say goodbye to everything he knew, from the ground to the sky. Goodbye, lions and zebras, I will miss all of you, and monkeys and giraffes, I won't forget you. Mugambi packed his suitcase, he looked up to the sky. Man in the moon, I have to say goodbye. Mugambi was moving to America. He was scared and sad. You'll make new friends, said Mugambi's dad. It was late at night. Mugambi got on the plane. He looked out the window. Things won't be the same. From the plane window, Mugambi got on the plane. The man in the moon, oh, please come with me. Mugambi was really tired, and he went to sleep. He dreamt of Africa, where the monkeys leap. He was in America when morning came. There were many buildings, nothing was the same. There were many people, but no lions in sight. He looked for the moon, but it was not night. Animals live in America, but they're kept in a zoo. Going to visit them is what he would do. Mugambi left the airport, and there was a yellow car. It took him to his new home. It seemed so very far. Mugambi arrived to his home, then he ran to his room. He unpacked his suitcase, 'cause his bedtime was soon. He looked out the window from his new bedroom. He saw his old friend, the man in the moon. The end.
Okay, so Mugambi moved from Africa to United States, but he still could see the moon. Why is that? The moon seems to be always with us no matter where we are on Earth. So, well, back when we didn't know what was going on, there was a very, very observant person called Sir Isaac Newton. Newton is one of the most famous scientists in the world. For some reason, he would see things and he always asked why. But he didn't just ask why, he would experiment with things. And there's a story about him that he would look at apples falling from the tree. Now, he actually wasn't sitting under the tree. They kind of make that story up and they make him a little boy, but he actually was kind of more like an older young adult. And he would look and he goes, why do apples fall down and not up? Why don't they go sideways? Why do they go down? And they seem to all go down at about the same rate. So it hits him on the head at the same time. This made Sir Isaac Newton start to wonder about what is attracting. And he was the first one to really understand gravity and do experiments. He wanted to know how gravity affected everything. And he created different laws. In physics, that's the laws of gravity. And he also was able to invent different kinds of math. This is where math will come into scientists. He was able to see how things worked and confirm things by using different math. So Sir Isaac Newton is on the right-hand side there. Sir Isaac Newton was even more interested in how our Earth and moon and sun moved. We didn't know back then of these words. When you revolve, that means like the Earth going around the sun. That means we revolve around the sun. Now, we also rotate on our axis. On the side. So if we look at, let me look at this little, can everybody see that? Is that we rotate like this, and then revolve means that you go around. And this bothered him. He had no idea why this happened. Because if you look on the right-hand side, you see it says center of gravity. And he realized that if everything was perfect, then the Earth and the moon would go around each other perfectly. But that's not the way it does. And he realized because the Earth was larger and had more mass, it attracted the moon, which had less mass. And it almost was captured into the field of gravity. He also realized that the sun had the same relationship with the system of the Earth and the moon. And so this was revolutionary. We didn't know that this occurred like this. Like sometimes when you go outside at night and you see the moon, we just had a full moon, you could see it moving in the sky. And they didn't really know why that happened. And so Sir Isaac Newton said, well, I got to understand gravity more to understand how this is all working. So he came up with 3 laws. And I won't go through all the laws. That you'll learn in 3rd grade. You'll learn more about all these different laws. But let's think about certain things. Have you ever tried to push something heavy that had a lot of mass and you couldn't move it? Well, that's what this stick figure is doing. So here we have the little stick figure is forcing it, or it's pushing it one way, but it's not moving. But what it's doing is it's moving the other way. And so it is kind of conflicting it. And so it looks like it's standing still. And this is what we call inertia. Let's say that word, inertia. Inertia is when things are actually standing still, but not really, because remember, we're rotating and revolving all around. Now, also there's another force that Sir Isaac Newton found, that gravity is also pushing it downward. And the block there is pulling it away. So it's kind of like all these forces are working together. Now, we use it every day, but what Sir Isaac Newton did was he put the math behind it and he started to understand what this means. Now look at the little boy here. Somebody's throwing him a ball and he's stopping it. So motion will continue unless stopped. Now this is actually real important when you think about the outer space. If you throw a ball in outer space, it continues and continues until something like a planet or an asteroid gets in the way and it stops it. On Earth, we have several forces. Like in this case, the ball would be caught by the boy. That would be, he's kind of like pushing it away. It's being pulled to him. But there's also another force of gravity. So it would on its own, if it was thrown, fall back to Earth, because gravity is also pulling it. Aha! Have you guys been on a swing? I'm sure. Now, when you were a baby, you sometimes would go on a swing and you go, well, I can't move. And your parents would have to go behind you and push you. And then you still won't go anywhere. You just go back and forth a little bit, but you wouldn't be able to continue. If you look at the young adults or the kids on the right, you notice that they're using their body to move it. So what they're doing is they can go higher and higher. So here you have a push and a pull. You have opposites. So here was another law of motion. For every action, there is a reaction. For every push, there is a pull. For every positive, there is a negative. Scientists have never found a place where nothing's going on. You always have things in opposites. So if you understand that if you are pushed, then you have to pull to continue the motion. And the motion is defying gravity. Now so gravity can help us understand how to do fun activities. You probably have seen dominoes before. And some people will use dominoes to play a game of numbers, which is very good. But in this case, they're using it to make a structure that will fall down with just one push. So somebody is pushing that initial one. And the way this is designed is that they will all fall. Gravity will take them all down because their center of gravity has been taken down. And so that one little push can cause a continuous reaction. So let's take a look at what Phoebe has there. What do you think she has there for us? It looks like a ladder, but let's see what they are.
These are toys that children played with in the early 1900s. So let's try this big one first. Okay, and now this little one, let's see if it does the same thing.
Okay, now I'm sure all of you now know why they're going down. That is gravity. But how is this designed? Let's take a look at this again and look at the size and see if it is going back and forth or is it just going all on one side. This is important. Is it moving or is it moving in a certain motion? And notice that the little one is just a smaller copy of the larger one.
These are toys that children played with in the early 1900s. So let's try this big one first. Okay, and now this little one, let's see if it does the same thing.
Now this is what we call, can you guys see this in my hand here? This is the little thing that Phoebe pushed down. Now, if you notice, one side looks exactly like the other side. And these are designed to do center of gravity so that when gravity holds it, it's equal on either side and it will just flip down. That's how it gets to the bottom and that's how the toy works. So exactly on this one, same thing. One side is equal to the other side. And these, the woodworker would make these by hand. And so gravity makes this toy work. Marbles. Now you guys can play with marbles anytime, but some people get really good at it because they practice and they learn that their force, when the force hits another marble correctly, it can either go this way, it can make different angles. So it can make a, depending on how it's hit. So if this is a marble and I'm hitting it, then it will go in a different direction. And so people who really like marbles can figure out how to make them work. I know when we were a kid, we used to play marbles and I used to be real good at it because I liked physics back then. And I was able to know how and where that little marble would go. Because back then what would happen if you got inside a ring, then you would get the marbles. So I would always have most of the marbles. So it's not a trick, it's learning the physics. Aha, center of gravity. Now, Phoebe is going to show you two dragonflies. This is another little toy. One is perfect and the other one is broken. And let's see what happens.
Let's take a look at this toy here. So if we take this dragonfly, we can get it to stay on the flower like that. But if we take this one, we can't get it to stay. And why do you think that is?
Well, that's because there's no center of gravity. Let's think back to the little presentation of the little boy kind of wobbling. His center of gravity, he could not control his balance. And that's exactly what's happening here. These little toys are engineered to use balance or gravity, so it looks like it's levitating, that it's kind of unique. So let's take a look at this again so you kind of can see the difference between the broken dragonfly.
Let's take a look at this toy here. So if we take this dragonfly, we can get it to stay on the flower like that. But if we take this one, we can't get it to stay. And why do you think that is?
Now you can play with this and get your own balance. You don't have to have these toys. You can use anything. A lot of people like to use spoons and their nose. So you can put the spoon on your nose and see if you can balance it. And you'll see that you have to move your head in many weird ways so the spoon doesn't fall, or a popsicle stick, anything. You can even to just make any kind of balance, okay? You have to find that center of gravity. Uh-oh, how many of you go bowling? Well, Fremont doesn't have any more bowling alleys. So you'd have to, I guess, go somewhere else to go bowling. But notice there's a ball and pins. Now notice how the ball curves. Good bowlers can know that spin. And notice how it hits one. The first one goes over to the right, and then the other spin takes care of the left. And so this is all good bowlers. They might not realize it, but they know how to counteract gravity. Look at that. And so a lot of times you have to control that ball in order to make it go down. Now, you don't need a bowling alley to do this. All you need is some pins, and you can get old buckets or something. And let's take a look what you can do. You can get, usually they call them 9-pin bowling. They used to use this in the Revolutionary War. This is how kids used to do bowling when they didn't have bowling alleys. But right here, why do the pins fall differently? So let's take a look at the first one. Let's look at the second one. Now, which one had more force? Was it the first one, or the second one? Well, the second one, obviously, because they fell. So what the ball was doing was getting the pins. You got something, a ball, and you forced it to hit the other pins, and you were trying to get the center of gravity off. Again, these pushes and pulls. Let's take a look at this again. This one had hardly any force. And this one had more force. And you could do this with anything. You could use them with cups. You could turn the cups upside down and just get a ball and see how good you are to make the pins fall. Okay, another game of skill is pool. Now this one, if you're a good pool player, you know exactly where to hit your force and where to hit the different balls. And then the game is that all the balls go in the pocket, and the winner is the one that gets all of their balls in the pocket. But this is a game of skill, and actually it is a game of physics, hitting the ball just correctly with the right amount of push to get a pull. So there you go, opposites. Okay, acceleration. Wait a minute, can you get cars to move faster? Well, you know that your parents, when they're driving a car, I hope none of you drive a car, but if your parents are and they put on the gas, that makes it go faster, okay? Now that's what Sir Isaac Newton learned about acceleration. How can you make things go faster? And that, well, we'll see how we can make things go faster in a little bit. So this is and that word should say being push, but of course it says push, okay? So let's look at Phoebe with a little experiment here.
Let's do an experiment. Let's see how high we have to put the marble on the ramp to get it to complete the loop. This is level 1. So not quite. Level 2. And level 3.
Okay, guys, which level? Was it 1, 2, or 3? It was 3. Now, why in the world would 3 be better than the bottom ones? Well, that's because gravity accelerates something. Accelerates means go faster. So let's say that word too. Acceleration. Acceleration lets things go faster. And on Earth, if something drops, it's accelerating. And so what Phoebe just showed you was that you had to have more energy as you were higher. And so and later on, you'll learn about potential energy before she drops it, and then kinetic. That means when it's actually doing and creating some energy. Physics can get very complicated, but first you even kindergartners can be little physicists. You have to observe to try to later on explain them. Okay, now this even and uneven forces. Now most of you have been on a seesaw, and you know if there's a big one, like the big cat at number 1, it could stay down. But how do you counter that? And you'll notice that in the middle, and this is what we call the fulcrum, the pink thing in the middle, that is trying to make the center of gravity equal. And so the fat cat can be countered by two medium-sized cats. And then they can go back and forth when you have a balanced force. Now let's look at two. That looks kind of unbalanced. You have the red team of one person, and then you have the gray team of 4 people. Now, how in the world is it being even? How come nobody's winning? Well, that means the red team is much stronger. One person can be as strong as 4 people. Now, so you're pushing and pulling, going back and forth. And you got to remember, if one of them loses their grip or can't make it anymore, their center of gravity will take over and they will fall down. Okay, now let's take a look at this. I have number 1, 2, and 3. This is what we call a pendulum. Now on Earth, on an ideal Earth, the pendulum would go back and forth, and never stop. But if you notice, one of these is stopping. Which one is stopping? Let's take a look. Number 1, it's going back and forth, and it doesn't look like it's stopping. Number 2, back and forth. Oh, and it slows down, and it stops. Number 3, it's going at the same level, and so it's not stopping. On Earth, number 2 would be the force of gravity, where it is stopping its motion. And that's where gravity, where if motion isn't going, it kind of gets in the way. Okay, now here's the guy with the apple again. Now notice the man is kind of pushing it upward, and then the gravity is pulling it down. Now, is there ways to get rid of gravity? Because if gravity always stopped everything, how can things work? Well, that's when you get engines and you get things like springs, so that we can engineer. Humans are smart enough, and I know all of you, when you guys grow up, you'll be able to figure out how to move things with understanding how to defy gravity. There's many, many ways, and you'll be learning them in your lifetime, how to move things and to get away from the gravity. Now, these are some little things that you can do at home. This is called a cup and ball. Now notice here, notice what is that, a monkey, a funny looking monkey? The monkey is trying to grab is that a ball, or is it a coconut, or is it something weird? I don't know what it is. But as it falls down, he's trying to catch it. So the gravity, you have to take into effect that the gravity is moving it, and so where you wanted to get it won't work anymore. And so this is what the cup and ball does. So let's look at what Phoebe is now going to show you.
This is a ball and cup toy. So what you're going to try to do is toss the ball and get it inside the cup. So one thing to think about is why we need this string here. And you can actually make this at home too. So you just need a small paper cup, and you can just poke a hole through the bottom like that, and then grab a piece of string or yarn and thread it through the bottom and tie a knot so that you can't pull it through. And then you're just going to tie a little rubber ball or a little toy at the end of it like this, and then you're done. So then you have a little cup and ball.
So what the cup and ball is basically doing is you're trying to find where the ball, so the force of your hand as you move it up, and as it comes down, you want to get it underneath it, so you're trying to find where the gravity will bring it. And so it's a good eye motions way to learn how to do this, but it actually increases your motor skills. So let's take it another one. And this, for parents, we have online. so you can actually make your own experiment to see if you can balance an airplane. So let's look at this airplane here on this animation. On the airplane, it has to be all the center of gravity. If something, like if it hits something, the center of gravity, and that's many times why you get an air crash. So what we're going to do is you guys are going to experiment with different paper airplanes, and you're going to see how you can make your glider defy gravity. Now, how do we defy gravity? That means you're going to engineer a shape that it can go through the air, because remember we got atmosphere, but then the gravity at the end will bring it down. And so this worksheet that Phoebe is going to go through will be able to show you kind of what you're doing. So Phoebe, are you ready?
Mm-hmm. So today we're going to be folding a paper airplane. So you'll be able to find this worksheet if you follow the link, and then all you're going to need is a big rectangular piece of paper like this. So it doesn't have to be printer paper, it could just be any kind of scratch paper or even paper you receive in the mail that you don't need. So we're just going to follow these directions, and the first step right here is to fold it in half the long way. So we want to make sure we fold it perfectly in half so that the two sides are even, just like that. And then we're gonna fold in the top corners. So we're gonna keep our finger here on the middle line that we just folded and fold the corners down just like that. And the same thing on the other side. Okay. And now that these top corners are folded, we're gonna fold the sides in. So we wanna make this edge in line with the middle fold that we made earlier. And you're just going to press down to keep that paper folded. And then same thing on this side. So we're going to bring this corner in and line it up in the middle. Just like that. Okay, and now when we're at this step, we're going to fold the two halves together, closed. Just like that. So now we have a big long triangle, and we're going to take one flap of it like this and fold it outward. And press down really hard to make sure your paper is folded nice and tight. And then we're gonna flip it over and match it. So we're just gonna fold this wing over so that it lines up with the other side, just like that. Okay, and press everything down to make sure it's folded nicely. And then we can unfold it. So see, it's starting to look like a plane right there. And then this last step here is just to fold up the corners of the wings like this so that we can direct the airflow. So when we throw it, the air can flow nicely and our plane can fly nice and straight and go far. Just like that. So now we have a paper airplane. So now we're going to come over here and test it out as we fly it. So here I have a couple of planes, but they're all folded in the exact same way. So we followed those same directions for all of these. Okay. So first, there's nothing on this plane. This is just like how we folded it, and we're going to see how it flies. So you're just going to grab the hold right here at the bottom and toss your hand forward. So we can see that flew nice and straight because the center of gravity is in balance and the plane is able to fly. However, if we change that with something like a paper clip, so here I have two paper clips, and I'm going to put them onto the wing of the plane, just like that. So you can think about, what is this paper clip doing to the plane? This paper clip has mass, right? It has some weight to it. So now, since both paper clips are on one side of the wing, this side of the plane should be heavier than this side. So let's see what that does to the motion and how it changes the plane's flight. So we're going to do the same thing. We're holding at the bottom. We're going to toss it.
So you can see that plane just kind of flew and fluttered down to the ground, right? Didn't fly straight like the other one. So you can try this at home too, just following those directions and folding a plane and grabbing any kind of bobby pin or paper clip and attaching it to different areas of the plane and seeing how that changes. So you can also attach the paper clips to the ends. And this is like an experiment, right? So you can try lots of different times and see how different things change your plane's flight.
And they can record it. They can record it.
Oh yeah, and you can record this so that you can see exactly how the plane flies. And you can also show your teacher and just show them that you tested this out. So you can have your parent also just record this on their phone.
They can decorate it.
Oh, and you can draw, and if you would like to just grab some markers, colored pencils, you can design the planes however you like, color them in, write your name, and just have fun with it. So now we're gonna test it out with the paper clips at the end. So same thing, we're gonna toss it up. And see, it flies a little bit, but it drops down because that center of gravity is off balance. Okay. And you can test this out with different numbers of paper clips and all kinds of different ways.
Okay, guys, so what we're going to do now is we're kind of finished with our presentation, and we'd like to take anybody who might have questions. So if you have questions on the presentation, because you guys were awful good, you sat down for 45 minutes. That's great for kindergartners. And let's see if there's any questions. So I'm assuming, and if teachers want to add anything that we could have done better, and I'm going to unshare this. This is going to be up online. We're going to give it to the district, and they're going to actually put it online. So I'm going to escape.